Coming up on this episode of Destination Tomorrow, we take a look at a new device that may help give doctors a type of X-ray vision. We'll also find out about a unique spacecraft designed to help scout out locations on Mars for future human missions. And we take a look back at the history of the space shuttle. Plus, Johnny Alonso finds out how sonic booms work. All this and more next on Destination Tomorrow. Hello everyone, I'm Kara O'Brien, and welcome to this edition of Destination Tomorrow. For many years now, NASA planners have been sending different types of spacecraft to Mars to answer basic questions about the Martian atmosphere, mineralogy, and of course, to find out if life exists there. Although these missions have been very successful in answering key scientific questions, it has been determined that we need to change our focus towards issues relating to human factors. With the agency's new push to have human crews at Mars by around 2030, there's a need to begin looking at the challenges associated with getting crews there. Researchers will need to spend a great deal of time looking for suitable landing sites that are free of dangerous obstacles, have sufficient amounts of water, and are scientifically interesting. To help in this task, a spacecraft called the Mars Reconnaissance Orbiter has been designed to help pave the way. Jennifer Pulley finds out more.
Although the first planned human missions to Mars probably won't take place until about the year 2030, NASA planners are already beginning to gear up for them. Literally millions of key decisions are now being made to help ensure the success of human flights to Mars in the future. Of course, one of the most important decisions that must be determined early on is where to land our crews. Planners need to find a landing site that is not only free of dangerous obstacles like boulders and craters, but there must also be scientifically valuable points of interest, and of course, water close by is a definite plus.
To help prepare the way for these human missions, NASA planners have developed a unique spacecraft called the Mars Reconnaissance Orbiter, or MRO. Now, this spacecraft will use advanced science instruments and high-resolution cameras to scout locations of interest and possible landing sites for these human missions. To help us understand how the Mars Reconnaissance Orbiter will work, I spoke with Scott Streepy here at the NASA Langley Research Center to find out more.
Well, the Mars Reconnaissance Orbiter is a multi-purpose spacecraft that's designed and built for the next NASA mission to Mars. Basically, the orbiter will continue NASA's exploration theme of follow the water. It will be on a very small science orbit and will be looking for water ice, vapor, and liquid water on the surface, in the atmosphere, and even below the surface. Also, it'll be able to take some of the highest resolution pictures ever taken of Mars, and from that, NASA scientists can evaluate potential landing sites for future robotic and human missions. Also, after the primary science mission is completed, it will become a communication relay for future Mars missions.
So how is the MRO mission different from other missions to Mars?
Well, this particular mission has a high-resolution camera on board. It will take more detailed pictures than we've ever been able to take before.
Carrying the most powerful telescopic camera ever flown to another planet, the Mars Reconnaissance Orbiter will be able to show surface features on Mars as small as a kitchen table. This high-resolution camera will provide a wealth of information about possible landing sites by photographing the Martian surface in unprecedented detail.
Now, how is this high-resolution camera different from other cameras used on other missions?
Well, this will be able to show things on a much smaller scale than we've ever been able to get on Mars. You can get details of boulders and surface features that we've not been able to take with pictures. For example, there'll even be investigations to try to go and find the Mars rovers that are currently there, and maybe even look for some of the spacecraft that we lost previously to see if we can better understand why those didn't complete successfully.
Because the camera and 5 other science instruments will produce huge amounts of data every day, the MRO has been designed to send information at 10 times the rate of any previous Mars mission. An added benefit to the MRO is that it will continue to be used as a communications platform for robotic missions of the future, long after its initial 24-month science phase is complete.
It also has a new suite of instruments that we've never brought, except for some instruments that will continue to look at the weather patterns of Mars to understand how the weather impacts the motion of the water on the surface and in the atmosphere.
Now, Scott, what is your role in the Mars Reconnaissance Orbiter mission?
Well, I lead a team of NASA engineers that supports the Jet Propulsion Laboratory's navigation team during the aerobraking phase. Here at NASA Langley, we have unique capabilities in aerodynamics, aerothermodynamics, thermal analysis, and flight mechanics. We're bringing all that in to help the Mars Reconnaissance Orbiter mission during that critical aerobraking phase.
Aerobraking sounds like aeronautics and braking. I'm assuming this has something to do with slowing the vehicle down?
Aerobraking is a technique that you can reduce the size of a spacecraft's orbit without using very much fuel. And in fact, the Mars Reconnaissance Orbiter, when it arrives at Mars, will use its engines to put itself into a fairly large elliptical orbit. Instead of using additional fuel to make that a smaller orbit, what it will do is skim the upper atmosphere of Mars over a period of 6 months. And every time it goes through the atmosphere, it'll lose some of its orbital energy through atmospheric drag. But you have to be careful, because if you go too deep in the atmosphere, you could cause major components to overheat and thus damage them. By using aerobraking at Mars, MRO is able to save hundreds of pounds of fuel. And what that means is we don't have to send all that weight from Earth to Mars, and we can use maybe a smaller rocket or use that weight for something else like the science instruments.
So Scott, what is the expected length of this mission?
Well, after aerobraking finishes, the primary science mission lasts 1 Martian year, which is about 24 Earth months. After that's completed, that's when it will become a communication relay for future missions.
Now, the term reconnaissance means that you're looking for something. You said you're looking for water. What else are you searching for?
It'll help the NASA scientists investigate future potential landing sites for other robotic missions, but also for the human missions that are coming.
So, Scott, finally, what are your overall expectations for the MRO mission?
I'm really excited about the MRO mission. Not only do you have subsurface radar, very high resolution images, the search for water in all 3 forms, looking at the weather patterns, and the ability to send detailed information to and from future landers. I think MRO is uniquely positioned to be able to not only expand our knowledge of Mars, but also continue our recent success at Mars.
The Mars Reconnaissance Orbiter is scheduled to take about 7 months to reach Mars and an additional 21 months to take its measurements. But researchers believe that it will continue to be a valuable communications platform for many years to come. Coming up, we'll find out about a new device that may give doctors a form of X-ray vision. But first, did you know that one big concern for future human missions to Mars is the Martian dust? Because Mars has a very thin atmosphere and has about 1/3 the gravity of Earth, the dust on Mars reacts differently to wind than the dust here on our home planet. The smallest dust grains on Mars are as fine as cigarette smoke and can simply hang in the air, potentially causing breathing problems for astronauts if it gets introduced into the spacecraft. This dust can also form into tornado-like dust devils that can reach as high as 5 miles, producing huge storms that can engulf the entire planet. NASA is known for its breakthrough technology in aeronautics and space, but few people realize how important NASA research has been in advancing medical technologies. Although this research rarely specifically attempts to develop these technologies, many of its discoveries are spun off and used in the creation of new medical devices. One of the latest inventions that has benefited from research performed at NASA is something called Artemis. This new device has the potential to make some surgeries much safer and will help to save lives. I had the opportunity to visit the laboratory at Analytical Mechanics Associates to help understand how Artemis will work. The history of medicine has a somewhat checkered past. From its earliest history until just before the beginning of the 20th century, many of the earliest practitioners were only able to provide the crudest forms of medical assistance to patients. For years, spiritual healing, bloodletting, and herbal remedies were generally the only form of medical help available to the average person. But this began to change in the late 1800s as advancements in medical practices began to move at a rapid pace. Perhaps one of the most important advancements during that time was the development of the X-ray in 1895. With this device, doctors finally had the ability to peer inside the human body without having to perform surgery. Since that time, this unique machine has proven to be invaluable, allowing doctors a 2-dimensional view inside of the patient. Although this technology has been a revolution, the 2-dimensional pictures were not appropriate for all types of soft tissue imaging, such as those used in cancer diagnosis and in heart procedures. So, in 1973, the introduction of the CAT scan again revolutionized the way doctors could see inside patients. This device for the first time allowed doctors a 3-dimensional view of the body and was especially helpful in looking at soft tissue. So what's the next revolution? Currently, researchers using NASA technology are developing a device that could give doctors a type of X-ray vision. Using a CAT scan in conjunction with virtual reality, researchers have developed the augmented reality technology for minimally invasive surgery, or Artemis. This system may soon be helping to make surgeries much safer and much less invasive. I spoke with Bishant Shanawaz of Analytical Mechanics Associates to help us find out how Artemis may be used in the future.
Artemis is a state-of-the-art technology that fuses augmented reality technology with fiber optic shape sensing. The augmented reality part takes 3D images of a person's anatomy and superimposes it over the real patient itself. So this enables doctors and physicians to be able to take these 3D images and look at them exactly where they are on the real patient. The fiber optic shape sensing portion allows the doctor to see the shape and hence the tip of the needle or the RF catheter or whatever device he chooses to insert into the patient.
So can you explain to me exactly how this will work?
The patient goes into a CAT scan machine. You get CAT scans of the patient. You assemble that into a 3D model. You then take the 3D model and project it onto the screen. You then register the 3D model over the actual patient, and then the doctor can see where exactly the organs are. You then stick the needle in with this fiber optic shape sensing technology from Luna Innovations. You insert it into the patient. Once the doctor inserts the needle into the patient, the doctor can see where the needle is going. The doctor guides the needle to the exact spot, burns out the tumor, extracts the tissue, does whatever the procedure demands.
What are the issues these days with the way doctors are using CAT scans in some surgeries today?
The problem today is that the doctor has to look away from the screen and look at the CAT scans or 3D images without looking directly at the patient. So he's trying to poke the patient, but he's looking at something else. If you ever try to do something while looking at something else, you'll kind of realize what the difficulty is. But that's the general problem, is that you cannot see where you're going. You cannot look at what your target lesion is or what your target organ is, and you cannot see your needle once it's been inserted. It's kind of like, it's pretty much groping in the dark.
That amount of pressure, so we reduce pressure.
The Artemis system holds great promise for use in minimally invasive surgeries. Because these surgeries generally use probes, catheters, and needles to perform the work, the real-time virtual look inside the body will improve the quality, safety, and efficiency of procedures. With tens of thousands of minimally invasive surgeries being performed each year, the addition of the Artemis system will undoubtedly save time, reduce cost, and most importantly, help save lives.
This device gives the doctor direct X-ray vision into the patient. So the glasses are what you use to see the stereo image. What happens is the system draws one image as if it's been seen with your left eye. It draws another image as if it's been seen with your right eye, and it shutters it fast enough, and the glasses shutter in sync so that you're looking at your right eye, you're looking at your left eye and your right eye, and when you look at them together, it does it so fast and it syncs it together. That way it looks like you're looking at a 3D image in real life.
Now, what types of NASA technology was used to help you develop this?
As you know, with NASA, we've used virtual reality and visualization for ergonomic design of the space shuttle and for different other types of aerospace concepts. We've decided to take that technology and extend it to the realm of augmented reality and apply that to medicine. Very excited about this technology. It's actually, we're pretty sure that it can actually make minimally invasive surgical procedures a lot safer. It's going to make medical care from that perspective a lot less expensive. It's going to minimize the time for people to wait and the time for these operating procedures. And we envision that at some point it can be applied to things such as beating heart surgery. That's kind of like the holy grail. So there's so many things that we're looking forward to actually doing with this, and we're very excited over here.
Towards the end of the Apollo program, NASA officials were already thinking about what would be next for the American space program. At that time, the rockets used to place astronauts and equipment into space were designed to be used only once. Although effective, NASA planners decided that they needed a system that was less expensive, reliable, and perhaps most of all, reusable. The idea of a reusable space shuttle that could launch like a rocket and land like an airplane was appealing and would soon change the way astronauts